Okay, we left off discussing no solution, infinitely many solutions, and one solution. And we determined that no solution is any time that my x's match, but my numbers don't. So here I have 5, here I don't have anything. So just as a quick review, that could be 2x minus 6 equals 2x plus 2. No matter what I plug in for x, that will never work. Or at the end, I could have a number that just doesn't work. Let's see what did work out here. If I subtract 2x from both sides, and I add 6 to both sides, I would end up with 0 equals 8. So that's always a no solution. Infinitely many solutions, I have the same number of variables, and I have the same number. So that when I was done, I would end up with an equation that 0 equals 0, but I can recognize that whenever I see that my variables are the same on both sides, and so are my numbers. Well, one solution. Well, all that means is, hey, my variables didn't match from the start. If they don't match from the start, it's going to be one solution. So 3x plus 2 equals 5x. So if I see right from the start, I've got 3x's on this side and 5x's on this side. So that means that I'm going to be able to get an answer. I will end up with a solution. So I'll subtract 3x from both sides. My x's go away and I have 2 equals 2x. Divide by 2, and x equals 1. So the only answer that I can have to make this work is if x was 1. So if x isn't 1, this doesn't work. There's one solution and one solution only. Okay, let's go ahead and go to my next step. So we want to determine, is this one solution, no solution, or infinitely many solutions? So let's go ahead and try this out. 6 plus 0.5y equals negative 6 plus 0.5y. So when I did the math. Now they look so similar, they look like they should work. I have a 0.5y on this side. I have a 0.5y on this side. But here's where it strays. This is a positive 6. This is a negative 6. So at this moment, I can determine variables are the same. Numbers are not. I could never make this work. This is a no solution. So that is a no solution problem. Let's move to our next one. Once again, we want to know, can this get an answer? So our room's floor is y meters long. So let's draw. So it's y. Okay? Its width is 5 meters shorter. If it's 5 meters shorter, then it's what I started with minus 5. Okay? So I had a y for a side, because that's what it told me its length was, and its width is 5 shorter. So that means I had the y already, but it's 5 shorter, so minus 5. Well, if I look, it asked me for perimeter, so I need to know what everything is. So if I look at this, I have 4 y's total. So I have 4y. And then I look at my numbers, minus 10. And perimeters add up all the sides. That's got to be equal to my perimeter. And this says that the perimeter is 4y plus 1. So we look at this. We go through what we know. My numbers are the same. My variables are the same. I have 4 y's on both sides. But as we look, my number is a negative 10 and a positive 1. They don't match. I can never find a situation this will work for me. So this is no solution. Okay, if it would have ended up just, if it would have been, it's a half a foot longer, then I could have had y minus 0.5. And then that would have ended up 4y minus 1 equals 4y minus 1. If that would have been the situation, we can look at that and say, hey, that's infinitely many solutions. That's just an if that had nothing to do with the problem. I changed that right there. This we want to solve for x. Okay, well, let me just check one thing. There we go, I skipped 2. I knew there was a solve for y first. We need to solve for y. If I want to get y, I got to get it by itself. So I'm going to subtract 3x from both sides. We've been talking a lot about this expression right here in class because that's going to be our next chapter. So we're getting used to how to write like this. So I subtract 3x from both sides. And I let those disappear. And I got 2y. Well, I can't subtract 3x from 6. So that equals negative 3x plus 6. And you notice I have my y's, then my x's, then my b's. Well, I need to get y by itself, so I divide by 2. And I divide this by 2, which means I'm dividing every part by 2. So y equals negative 3 halves x plus 3. All right, so there's my solution solving for y. Now I can also see from the stuff we've been learning, just to throw it in, that would be my m. M is slope, so the slope of this line would be negative 3 halves. And my b is at the end, that's positive 3. That would be my starting point, my y-intercept, as we've talked about. But let's go ahead and go with what this question's asking. I wanted you to make a t-table, and we've already put 3 numbers here. So if x is 0, if I throw a 0 in for x, it's negative 3 halves times 0 for x plus 3. So this would be a 3. If I go ahead and put a 1 in, I have to put a 1 in there. Negative 3 halves times 1 is negative 3 halves plus 3. Well, negative 3 halves I can also call negative 1 1/2 and a positive 3. So that would be 1 1/2. Oh, was that supposed to be a 2? That's my bad. I'm so sorry, guys. Let me go ahead and put a 2 in there. I didn't even look at my question. So 2, that would be negative 3 and a positive 3, which is a 0. And in my last one, it's a 4. So I put in a 4 in for x. Look at this, negative 6 plus 3, or that would be negative 3. And I know I'm going fast. I hope you can do the math out on those. Just try to make sure we get through it. Okay, next we're solving for x. There's no difference solving for x than there was solving for y. I just want to get x alone, so I'll subtract 3y from both sides. And I get 4x, but for x equals negative 3y plus 8. Now I'll divide by 4. Divide by 4, and I get x equals negative 3/4 y minus 2. Oh, sorry, plus 2. I said that wrong. So that's plus 2. Now, it tells me I want to try a 0 in for y. If I try a 0 for y, negative 3/4 times 0 is 0, plus 2 is 2. Next, we want to try a 1 for y. And these are just numbers we arbitrarily made up. You could put anything you want in for y, and it will give you its corresponding x. But here I have a 1. Negative 3/4 plus 2 is 1 1/4. Put a 2 in. Negative 3/4 times 2 is negative 3 halves, or negative 1 1/2 plus 2. So I'm left with positive 1/2. As we see, this is shrinking as y goes up, x goes down. Okay, here we go. So a parking lot charges $2.25 for the first hour and 60 cents per 15 minutes after that. Write an equation for the cost. Let's look. As we've been working on y, x, m, b. So my y here would be how much I'm going to pay. That'd be my cost for parking in the parking lot. X is going to be how long I'm there. So how many 15 minutes? How many 15 minutes was I there? 15-minute intervals, I should say. M, my slope, that's my rate. That's my cost per 15 minutes. And my B. B is my starting point. It's what I paid at the beginning. I paid $2.25. And that's your up front. So that's your $2.25. That's your beginning cost. So let's go ahead and write an equation here. So I've got y equals. We'll throw my m in. My m is the cost per every 15 minutes. That's 60. Times x. How many intervals do I pay for up front? I'm going to pay for 4 of them. I'm paying for an hour no matter what up front. So I'm going to take away 4 of my intervals. Okay, because each one is a 15-minute interval, but I'm not counting that one. Okay, plus, I got to pay my $2.25 up front. Okay, so let's go ahead and add all this in now, and I get y equals 0.6x minus 2.4 plus 225. So we go ahead and we do this out, and I get y equals 0.6x. That will be minus 0.15. That means that it was cheaper for the first hour than it will be for any other hours. Because if I'm paying 60 cents per hour, that's $2.40 that I should have paid for the first hour, and they only charged me $2.25. Now I can go ahead and find out how much it would cost me no matter how many hours I stayed there. If I was there for 3 hours, and there's 4 15-minute intervals in an hour, I would just say 0.6 times 12 minus the 15 cents. Oops, I should have done that on that spot that I made. Okay, in the number pattern, 4, 10, 16, 22, each new number is 6 greater than the previous. Use the formula L equals 4 plus 6 times n minus 1 to find the L number in the nth position. Meaning no matter what position, if I want to know what the 10th number is, then I can find it out. Okay? If I want to find the first number, I can find it out. I can look at it. The first number is already 4. But I can find out if I put a 1. So we're going to say we want to know the 9th number in this. We want to find the 9th number. So all I got to do is say L equals 4 plus 6 times 9 minus 1. Or which we know is 8. So L equals 4 plus 48. Or that would be 52. And let's see if that really would be. If we're adding 6 each time, 22, 28, 34, 40, 46, 52. What we match, that's the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth term was 52. And we found that by using the formula. Okay, let's go ahead and go on. A company prints 3 color print t-shirts for a $45 setup fee and $6.50 per shirt. First thing I want you to do is write a formula to find the cost of printing X number of shirts. Second, find the cost of printing 30 shirts. So the first, I got to find this out. And I see, hey, that 45, that's like a B. That's a starting cost. That's my upfront. That's my B. $6.50 per shirt. So X is going to be number of shirts, and $6.50, that will be my cost per shirt. And my Y in this is going to be total cost. So Y is total cost. So Y equals 650. Whoops. 650X, because X is my total number of shirts, plus 45, which was my upfront, my setup fee, or my starting point of the cost. Now the second thing it asked me to do was to find out for 30 shirts. So if it's 650 times 30 plus 45. Now we'll go ahead and do the math. I'm just going to do this fast for us because we're just about out of time on this video. So 30 times 6 is 18 and half of 30 is 15. So I've got $195 plus $45. So I did the mental math just to save us a second of time. And Y equals $240. So if I was to buy 30 shirts, now I can put in 40 for X and find out how much it cost me to make 40 shirts. 50 for X to tell me how much it would cost to make 50 shirts. Thank you guys. I know I went quick today. Hopefully you could see how to do some of these. Good luck studying. Hope you really catch on to these concepts.